before we can get to the good stuff in a thunderstorm, we have to understand a few basics, like how a thunderstorm even forms. So, as you can see on the paper, I got 3 simple steps. To get a thunderstorm, you have to have air rising, but that air has to be rising really, really fast. Now, it has to rise fast because I need my water vapor to condense, not just into droplets, but they have to be really, really big droplets. And so it's rising fast, all of it's rising right here, and it doesn't get a chance to spread out. So it's all gonna condense right here, piled on top of each other. And so my water vapor is gonna condense in a very narrow area into really big drops of rain. Now, really big drops of rain, not only do they fall really fast. Now, I don't know if you've ever been outside in a thunderstorm, but I think we can all agree that the rain comes down pretty hard during a thunderstorm. So, to get these conditions to happen, the most common place is, here's our friendly cold front. Again, a cold front is when you have cold air pushing in on the warm air that's in front of it. And along this edge, what we're gonna see again is that the air is gonna go up fast, condense fast, and then fall fast, which is the recipe for a thunderstorm. So, quick reminder from last week. As my cold air pushes into the warm air gets pushed upwards at a steep angle, which means it's gonna go up very fast. When it goes up fast, you get those puffy cumulus clouds. Now, if this air is really humid, as it goes up, my cloud is just gonna grow, and it's gonna grow, and I'm gonna get this big puffy cloud that grows all the way up to the top parts of the atmosphere, and this is called a cumulonimbus cloud that I can't spell. Cumulonimbus cloud. That was awful. Anyway, our cumulonimbus cloud is simply a thunderstorm. So, as you can see, the air is rising quickly, it's condensing into these puffy clouds, and what we're gonna see is some really intense rain going on right here. And that's the basics of how thunderstorms form. All right, now we are on to the inner workings of a thunderstorm and how that leads us to hail. So, for starters, we have what's called an updraft in every single thunderstorm. Now, shockingly, an updraft is when the air goes up quickly. Now, as it goes up quickly, we got our puffy cloud, our cumulonimbus cloud, and it's gonna form water droplets as it condenses. So these water droplets are getting shoved up by my updraft, and what you'll notice is they're gonna reach the freezing point. You know what happens to water droplets when they hit the freezing point? They freeze into ice crystals up in the top of this cloud. So the top of every cumulonimbus cloud consists of these ice crystals that get shoved up and over. Now, another part of a thunderstorm you need to pay attention to is what's called the downdraft. The downdraft is when the air comes down just as quickly. Now, these ice crystals are going to become part of this downdraft, and they are going to come down, but as they come down, they're going to melt back into rain. Now, this rain is going to be really cold. These big droplets, they're going to fall. If you happen to be over here in my thunderstorm, it's going to be rain, but I don't know if you've ever been outside in a thunderstorm. Those raindrops are really, really cold. That's because they're coming from up here where it's all frozen. So what you have going on inside any typical thunderstorm is an updraft and a downdraft, which creates a sort of circulation that you can see. Now what I want to pay attention to is these ice crystals right here that are right in the middle. What happens if they fall down right here because they're heavy? And they get pulled back up by the updraft. As they make that circuit right there, they're going to run into water droplets. As they run into water droplets, the ice crystal is going to get bigger, and it's going to get bigger as it keeps rotating. It's going to get bigger until finally my ice is so big, it's going to fall, and it doesn't matter about the updraft. It's just going to keep going on its way down, and I'm going to have these ice crystals falling down during my thunderstorm, and that is what leads to hail. Now, to get the ice crystals big enough to not melt on the way down requires this type of circulation. And the only place you can get this type of circulation is in a thunderstorm. Now we are on to lightning. Now, as you can see in my picture here, we've got our cumulonimbus cloud. You can see my updraft going in, my downdraft coming out. What you should also see is I've got a bunch of positive signs up here and negative signs down here. That's because in every thunderstorm, there's a separation of charges. The particles up here are overwhelmingly positive, and the particles at the bottom of the cloud, more importantly, are overwhelmingly negative. Now, the reason that happens is not 100% understood, but as far as we can tell, as the water goes up and forms ice crystals and circulates around, it bumps into other particles in the cloud, water droplets and such, and it tears off electrons. And so then those ice crystals carrying extra electrons go towards the bottom of the cloud because they're heavy. Extra electrons means you'd have a negative charge. The particles that are lighter, therefore, go to the top. They have less electrons, therefore they are more positive. Anyway, regardless of why it happens, this is what a cloud looks like in a thunderstorm. Negative at the bottom, positive at the top. Now the ground is electrically neutral, which has positives and negatives both. But if you have a thunderstorm close enough to the ground, remember, bigger, heavier clouds are going to be close to the ground. This negative charge repels these negative charges and forces them away. And what does that do to the ground? It's going to leave the ground with a positive charge. So now if I have a really big cloud with a negative charge and a ground with a positive charge, that leads to attraction because negatives are attracted to positives. Now, if there's enough attraction, some of these negative charges will actually physically flow towards the ground. So I'm going to give this some negative charges. So really what this is electrons flowing to the ground. Now, I don't know if you remember from physical science, but what is the flow of electrons? That's the definition of electricity. So if this is electrons moving, this is a bolt of electricity going from the cloud to the ground. Now in this case, since it's happening through the atmosphere, we have a special name for it, and we call it lightning. Okay, side note, lightning is really, really cool. I don't have time to explain really in detail how it happens and why there's different types and whether it actually comes down from the cloud or goes up from the ground to the cloud or whether it goes from cloud to cloud. In fact, all of those things happen. So if you get time, go to YouTube. There's tons of cool videos that explain it probably better than I could, but I don't have the time to go into it. It's really cool though. So if you get a chance, look it up. And now, on to thunder. So, before we can talk about thunder, we have to realize that thunder is just simply a sound. And so we have to understand a little better what a sound actually is, otherwise the explanation won't make any sense. So what we have here is a really poorly drawn picture of an ear. So these over here are air molecules. So let's just assume you're listening to something like maybe me speaking. When I'm talking to you, what's happening is I'm creating a vibration in the air. A vibration is simply when one air molecule runs into the next air molecule, which bumps it and causes it to run into the next one, which causes it to run into the next one, and this vibration, this energy, travels all the way until it hits your eardrum. Now, I just want to take a moment and point out, this air molecule did not flow all the way into the ear, it simply ran into its neighbor and then stopped. So the energy is going from particle to particle to particle, and that is called a vibration. Now, your eardrum gets vibrated by these air molecules running into it, and there are three little bones attached to your eardrum called the hammer, the anvil, and the stirrup. Now, these are the smallest bones in your body, and they transmit the vibration from bone to bone to bone until it hits this little snail-looking thing called a cochlea. Now, your cochlea is a fluid-filled organ in your inner ear, and you can see the edges of it are lined with little hairs called cilia. Now, this vibration goes through the eardrum, vibration passes through the bones, and then it gets passed through all this fluid inside here. And when it does, it makes these little hairs vibrate back and forth at the exact same rate. Now, these little hairs are all attached to these nerve endings that I've drawn, which go to your brain. So when these nerve endings get stimulated by the hairs, your brain interprets that as a sound. So that being said, let's go back to my thunderstorm. Negative charges at the bottom of the cloud, positive charges on the ground leads to attraction. The electrons flow, but this time let's pay attention to the fact that lightning is really, really hot. In fact, it's estimated to be about 5 times hotter than the surface of the sun, which is just ridiculous. So when it hits air molecules, here's my air molecules, they move away really, really fast because they now have lots of energy. But here's the problem. As they move away, you know what they're going to run into? Other air molecules. These new air molecules now get shoved away really fast because they have lots of energy until they run into other air molecules. And what's that create? Just like in the last page, that is a vibration. So this heat energy is being passed from particle to particle to particle until you're over here. That vibration reaches your ear and you can hear it and it sounds like thunder. So really, thunder is simply the noise created when the lightning superheats the air and causes it to expand.